So we are finished with polymers, right? Polymers chapter where you learned various types of polymers, right? Addition polymers as well as condensation polymers, various examples for each section. Today we'll start with a new chapter, amines. So amines, they constitute a major class of organic compounds, and they are derived from ammonia molecule or from ammonia by replacing the hydrogens that are there in ammonia molecule. So one or more hydrogen atoms in ammonia molecule can be replaced by an alkyl or aryl group. So alkyl or aryl group, you will get amines. So in nature, if you see, you can find amines in proteins, okay? You can find them in vitamins, you can find them in hormones, even alkaloids. In all this, in nature you will find amines, okay? Then synthetic, if you want, there are various, okay? They are present in dyestuffs, drugs, etc. Okay? So they are a major class of organic compound, or you can say they constitute a major class of organic compound. Now, as far as amines are concerned, since you get them or derive them from ammonia, you can also call them as derivatives of ammonia. So you have an ammonia molecule, go on replacing one by one. You replace one hydrogen with one alkyl group or one aryl group, or you replace all of them. Therefore, we derive them from ammonia molecule. So I can write, just to show you, minus H plus R. Okay. So what happens? You get R dash NH2. Then replace one more, minus H plus R. You get R dash NH dash R. Again you minus one hydrogen, add one alkyl. Now this can be aryl also. You get R dash N dash R dash R. So like this, you can derive them from ammonia molecule by replacing one or more hydrogens with alkyl or aryl groups. Therefore, you can call them as derivatives of ammonia. Okay. Coming to the structure of amines. In ammonia molecule, nitrogen is sp3 hybridized, right? So these three hybrid orbitals are used to form, or they overlap with the 1s orbitals of hydrogen to form 3 bonds. So you get dash H, dash H, dash H, and there is a lone pair of electrons on the nitrogen atom, and the bond angle will change. It is not a standard angle because of this presence of lone pair, so there will be lone pair, bond pair, repulsion, right? But here also it is trivalent in nature. In ammonia, nitrogen atom is trivalent. In similar manner, in amines also, the nitrogen atom is trivalent, and it undergoes sp3 hybridization, and the sp3 hybridized orbitals will overlap with either the orbitals of hydrogen or orbitals of carbon, depending upon the composition of that amine. Okay. And there is a lone pair of electrons on that nitrogen, just like in ammonia. Okay. and because of that the angle will not be 109.28. the stability angle will not be there because of that presence of unshared pair of electrons on nitrogen. Okay. Therefore, the C dash N dash E bond, okay, where this E is nothing but H or C. It can be either hydrogen or carbon, depending, as I told you, depending upon the composition. This angle that is there, okay, it is around, or you can say it is less than 109. It will not be, it will be less than 109 degrees. Okay. So if it is tertiary, for example, a tertiary amine, like for example trimethylamine or triethylamine, you see that the C dash N dash E bond is around 108 degrees. Okay. So just like in ammonia, nitrogen here is trivalent, undergoes sp3 hybridization. The hybrid orbitals, sp3 hybrid orbitals of nitrogen will overlap with the orbitals of either hydrogen or carbon, depending upon the composition of that amine. Okay. And the C dash N dash E angle, where E stands for either hydrogen or carbon, is less than the standard angle of 109.28. Okay. So as far as the tertiary amine is concerned, especially trimethylamine, the bond angle is around 108 degrees. So this is about the structure of amines. Then coming to the classification of amines. So amines are normally classified into three types, depending upon how many hydrogens are replaced by alkyl or aryl groups. So we start from ammonia. Right? If you replace one hydrogen by one alkyl or aryl group, you get R dash NH2. So this is a primary amine. Okay. Similarly, if I replace one more hydrogen, I get R dash NH dash R dash, or I write R1. So this is secondary. Similarly, if I remove one more hydrogen, I get R1 dash N dash R2 dash R1 R3. Okay, so this is tertiary. Understood? So amines can be classified into primary amines, secondary amines and tertiary amines depending upon the number of hydrogen atoms replaced by alkyl or aryl groups. So this is the classification of amines. Now let's go into the nomenclature. So in case of the old system, you can name the amine as alkyl amine. Okay. So we have to add the prefix alkyl to the word amine. So to name the amine. For example, CH3 dash NH2. So this can be named as, what is this? Alkyl, methyl amine. Or if I write C2H5 NH2. So it becomes ethyl amine. Similarly, if I have secondary one, for example, so here I can name this as dimethyl amine. Okay, suppose if it is here, I can write ethyl-methylamine like that. So you can name them according to the old system as alkyl amines. But according to IUPAC, to derive the name of an amine, what you should write? You should write the name of the alkane. So alkane you write, remove E and add the word amine to that. So it becomes alkan amine. So amines are named as alkanamines by removing E and replacing that E by the word amine. Therefore, suppose if I have CH3, it's the same one. So you should write, what is this? Single carbon, so methane. Remove this E, add amine. So it becomes methanamine. Similarly, if it is C2H5 NH2, it becomes ethanamine. Okay, suppose if you have CH3 dash NH dash CH3. So what you will do? You can write it as N comma N dimethan amine. Okay, so this is how you have to name the amines. So you name them as alkan amines by removing E of the alkane and replacing that E by the word amine. Okay, now let's go into how amines can be prepared in the lab. Therefore, one of the best methods of preparation is by reduction. So, reduction is the best process because using reduction I can convert nitro compounds into amines, I can convert cyanides or nitriles into amines, I can even convert the amides into amines. Okay. So for example, if I do reduction, the first method of preparation, first method is reduction of nitro compounds. Reduction of nitro compounds. So suppose if I take nitrobenzene, okay, so can reduce it using hydrogen or nickel with nickel or palladium or platinum with little bit of alcohol to aniline. This is amino benzene or aniline. Okay. Similarly, benzene and use SN plus HCl, or you can use scrap ion in HCl. Okay, to get so this is getting amines from nitro compounds. So nitrobenzene can be reduced using palladium or nickel in presence of alcohol to give you aminobenzene or aniline, or you can reduce using scrap ion in HCl, tin and HCl to give you your amines. Okay, so this is first method of preparation. It is reduction of nitro compounds. Similarly, the second method of preparation is from reduction of nitrites. Okay, so you can use a nitrite R-C triple bond N. Okay, and do the reduction. So if you do the reduction, you can use H2 bar nickel or palladium. You can use sodium bar C2H1. Okay, so this can give you R-CH2 NH2. This is your reduction of nitrites, where you can convert the nitrite into amine. Okay, similarly, we can also use the amines. So what is an amine? Amine is having the C double bond O dash NH2 group. This is attached to R. It becomes amide. And if there is no R and the C double bond O, it turns into amine. This is the difference between amide and amine. Okay. So next is reduction of carbon. That is the reduction of amines. Okay, so R dash CONH2 can be reduced using lithium aluminum hydride and AlH4, lithium aluminum hydride. Okay, presence of to give you R dash CH2 dash NH2. So amides on reduction can also give you the amide. So you have three reductions now. You can reduce a nitro compound or a nitrile or cyanide or an amide to give you your amine. So this is actually reduction using nitro compounds is first method of preparation. Reduction using cyanides is second. Reduction using amides is third. But what I did, I combined all of that into one, and since they are all undergoing reduction, so I said reduction of nitro compounds, reduction of nitriles, reduction of amides to amines. Okay. So this is first method of preparation. So now I just want to summarize what we did, because there are other important methods of preparation which we will deal with in the next class tomorrow. So we have Hoffman's bromide reaction, then Gabriel synthesis, Mendes reaction, ammonalysis. All those reactions are there, which are again methods of preparation of amines. So as far as this chapter, amines are nothing but they are derivatives of ammonia. How do you get these amines? They are derived from ammonia, so they are called as derivatives of ammonia. So you can replace one or more hydrogen atoms present in that ammonia by other alkyl groups or aryl groups. Okay, that gives you your amines. Now, as far as the structure of amines is concerned, the nitrogen atom present in amines is trivalent and undergoes sp3 hybridization, and the sp3 hybrid orbitals of nitrogen will overlap either with the orbitals of hydrogen or carbon depending upon the composition of the amine. Understood? And there will be a lone pair of electrons, unshared pair of electrons on nitrogen atom, and because of that the C dash N dash E bond is not the standard bond, bond angle is not the standard, that is, it is less than 109.28. In fact, for the tertiary amine, that is triethylamine, it is seen that it is around 108 degrees. Okay, so the structure is almost same like ammonia, it is almost pyramidal in nature. Okay. Then coming to the classification of amines. Amines are classified depending upon number of hydrogen atoms replaced by alkyl groups or aryl groups. So if you replace one hydrogen by alkyl or aryl group, I get R-NH2. This becomes primary amine or 1 degree. Then if I replace 2, I get R-NH-R, that is secondary. Then R-N-R. So I have replaced all hydrogens by alkyl or aryl groups. Then it is tertiary. Okay. Okay, this is as far as classification. You have 3 types of amines: primary, secondary, and tertiary, depending upon the hydrogen atoms replaced by alkyl or aryl groups. Then I told you about the nomenclature. So there are 2 ways. The old method or tribal system, we name them as alkyl amines. That's all we name them. Okay. But if it is IUPAC, what we do? We first write the alkane and then remove that E of that alkane and replace it by amine. So it becomes alkane amine. So I will give you an example. CH3 dash NH2, the simplest of amines, can be named as methane amine. So I write methane there, remove E, add me. Okay. So this is how you can name this compounds. Okay. Then I came to the methods of preparation of amines. So I repeat this again. Okay. So when you come to the methods of preparation, first method is reduction of nitro compounds. So you can take a nitro compound, nitrobenzene, and reduce it using H2 bar P NC2H5OH. Okay, so this gives This can be named as aminobenzene, or the common name for this compound is aniline. Okay, similarly, it's an alternate method also. You can use scrap ion and HCl to get your amine or convert the nitro compound into amine. So NO2, H2 bar, anion. Okay, or palladium also can be used. Sorry, I told you scrap ion and HCl. You can use SN, that is tin, and HCl, or Fe plus HCl. This also gives you amine. So this was the first method of preparation. What was the second? The second was reduction of nitriles. Nitriles are nothing but cyanides. Okay. What is the difference? It is CN. There is a triple bond between carbon and nitrogen. C triple bond N. So, in old nomenclature, these were called as cyanides or cyanide. You can also call them as nitrite. Okay. So, how do you convert these nitriles or cyanides into amines? Again by reduction. Okay, so you write R-C triple bond N. Now reduce using H2 bar nickel or palladium and little bit of sodium or mercury amalgam in C2H5OH. Okay, so this will convert into R-CH2-NH2. It's a, see, you have converted that cyanide or nitrile into amine. So by reduction. So this is the second method of preparation. Okay. Then we have reduction of, I told you, amines. Amines can also be converted into amines. So R dash, so what is the difference between amide and amine? Amine has R dash NH2 group, right? One hydrogen atom or more hydrogen atoms from ammonia molecules are replaced by alkyl or aryl groups. In case of amide, you have the C double bond O dash NH2 group. This is the basic difference. If you remove this, it is an amine. You add this, it is an amine. Okay. So C double bond O dash NH2. But you need a very powerful reducing agent here. You need lithium aluminum hydride. So that will reduce. And then after that, little bit of hydrolysis is also required. So that will give you R dash CH2 dash NH2. This is your amine. So amide can also be reduced to amines. Cyanides can be reduced, nitro compounds can be reduced to amines. So this is the first method of preparation of amines. That is reduction of nitro compounds, reduction of nitriles, reduction of amides. Okay. Similarly, you have other methods of preparation like the Gabriel synthesis. Then you have Hoffman's bromamide reaction. Bromamide reaction. Okay. Then you have ammonalysis.